Okie doke, welcome back. Now we're going to quickly go through the branched chain alkanes. Now these are alkanes that aren't linear. They do have a straight line in them, but they have a branch coming off the straight line. Now they can have one branch, they could have two branches, they could have three, and so on, depending on how many carbons there are on the longest chain. So we'll start with something easy. 2, 3. We'll go 4 carbons, and we're going to have a branch coming off the second carbon in this molecule here. Now, okay, so the first thing you need to do, step 1, is to find the longest chain. Now, in this molecule, there are 2 chains that are the longest because there are 2 chains that are made up of 4 carbons. There's one if you start here and you go 1, 2, 3, 4. There's also one if you start here, because this can become 1. 1, 2, 3, 4. Okay, so it doesn't matter which one you use, as long as you start numbering from the, in this case, the left-hand side, because on the left-hand side, that is where our alkyl group is. Okay, so you want to start from the side that is closest to the alkyl group when naming stuff. Now the alkyl groups are named the same way that alkanes are named. So for 1 carbon on the alkyl group, it's called a methyl group, and for 2 carbons on the alkyl group, it's called an ethyl group. Okay, you can't quite see that. Ethyl. For our unit, you are only expected to be able to name alkyl branches that contain either 1 or 2 carbon atoms. So we're only really going to deal with methyl or ethyl. So for our molecule here, we find the longest chain. It's 4. The longest chain of carbons is 4. That means this is a type of butane, right? And then we count how many carbons there are in the chain. Now, if we'll just use this bottom one here as the chain. There's only 1 carbon in this chain, therefore it is a methyl butane. So methyl butane. And it's important to name our methyl butane. We're going to number it. Okay, now the methyl group comes off the second carbon, therefore we're going to call this 2-methyl butane. Okay, right, pretty straightforward. Let's look at another one. Let's go to something. I'm going to go 6 carbons this time. 1, 2, 3, 4, 5, 6. And I'm going to put 2 here. Now these are CH3, 2, CH3, CH3, CH2, 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 and CH2. bam, bam, bond, 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 bond. Okay, so again, first step is to find the longest carbon chain. Again, in this molecule there are two of the longest carbon chains. Here is a CH3, not a CH2. Whoops. So if we count straight across from left to right, we can have 1, 2, 3, 4, 5, 6 carbons as the longest chain there, making this little section here our branch. Or we could count from here and go 1, 2, 3, 4, 5, 6, and have this little section as our branch. It doesn't matter either way. However, we're going to need to count from this side and start with 1 here or here, okay, because we want our methyl group to be closest to the starting side when we're counting. So this time I think we're going to go from here, just for something different. We're going to call this 1, we're going to call this 2, we're going to call this 3, 4, 5, 6. Okay, so our longest carbon chain consists of 6 carbons, which is going to make this a hexane molecule. Hexane. Okay, this time we have got a branch, but it consists of 2 carbons. Here, 1, 2. Okay, 2 carbons means in our alkyl group means that it's ethyl hexane. Ethyl. Okay, and again it's important to note that the ethyl group here is attached to the 3rd carbon in our molecule, so we are looking at 3 ethyl hexane. Okie doke. Okay, let's look at one more, something just a little bit trickier. Okay, let's have a look at this one. I'm going to do 4 carbons again. I like butane. Let's go 5 carbons this time. 1, 2, 3, 4, 5. Okay, I'm going to put another carbon here. I'm going to put a carbon here. And I'm going to put a carbon here. Alright. Like this. Should put some ones here. Rightio. So the last one we're going to look at. First step. Find the longest chain of carbons. So we can count straight across, 1, 2, 3, 4, 5. Or we could start from here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, we're going to roll with the straight chain through the middle here. We've got 5 carbons, so this is a pentane molecule of some sort. Pentane. Okay, we're going to label it from this side because we have 2 branches closest to this end. Four, 5. Now, we've got a branch on the 2nd carbon there, and we've got a branch on the 4th carbon. Okay, now all these branches are methyl groups because they only consist of 1 carbon each. We've got 3 methyl groups this time. We've got 2 on the 2nd carbon and 1 on the 4th carbon. So this is still methyl, but because there's 3 of them, we need to call it trimethyl. Now, if there was 2, it would be dimethyl. If there was 4, it would be tetramethyl. Okay, there's 3, so we call it tri, and we just need to note what number carbon they're attached to. So we've got a 2, a 2, and a 4. So this is named 2, 2, 4 trimethylpentane. Okay, that's enough for branched chain alkanes. I'll see you again next time.